Alright, so what is actually the concept? Before explaining this one, let me tell you about the derivative part. We had learned in differentiation that if you want to derivate ln of 5x plus 2, right? If you want to derivate that function, so the differentiation procedure is this: whatever written with ln, we need to write in the denominator, right? And then you need to find out the derivative of this function, that is 5. So the final answer is 5 divided by 5x plus 2. That is the differentiation of ln functions we have learned previously. So now in this exercise we are going to integrate the ln function, right? And how we are going to do that, it's not that much difficult. It says integral of 8 upon x d upon dx. So keep in mind that integral is the reverse procedure of differentiation, right? In differentiation, we find out the derivative of the function after writing the derivative in the denominator. Alright? So that means we can say that you can integrate it if the derivative of the function should be in the numerator. Alright? So firstly, if I write the expression in this form, 8 integral sign 1 upon x dx. It does not make any difference to the constant part. You can see that the derivative of x is 1. It is present in the numerator. So the integral is 8 and 1 upon x is ln x and plus c, as always we apply in indefinite integrals. Alright, so what you need to observe, what you need to focus, that the function that is in the denominator, its derivative part should be in the numerator. If it exists, then you can easily apply the ln function in that case. If you got it, it's very good. If you don't get it, no need to worry about it. We are going to attempt some more questions. Not part B and part C, part D, because that is a little bit different. Now we need to integrate 5 divided by 3x dx, right? First step, take the coefficient out from the integral sign. So it's 1 divided by 3x and dx, right? Now, what is the derivative of this function? The derivative of 3x is 3, so 3 should be present in the numerator, so I need to multiply it by 3 and 3. Alright, now this function 3x upon 3, it is ready to integrate, so I will grab this denominator 3 outside the integral sign because it's a coefficient, right? It's a constant. So 5 upon 3 integral of 3 divided by 3x and dx. Now it is ready to integrate. The derivative of the denominator is present in the numerator, so now you can integrate it. So it will be 5 upon 3 ln of 3x and plus c. Alright, so moving on to the next one. We have done part A, part B, and now part F. Integral of 1 divided by 1 minus 8x dx. First give it a try by yourself. Time is 2 minutes. Think about it and then I will tell you the answer, so stop. Alright, so what you need to do first, we need to identify the derivative of this function that is present in the denominator. So if you find out the derivative of 1 minus 8x, the derivative of it will be minus 8. Alright, that means we need a negative 8 in the numerator. So for that part we need to multiply. The function we have, it's 1 divided by 1 minus 8x and dx. We need to multiply the function by minus 8 and divided by minus 8, right? The derivative of the function in the denominator is present in the numerator. That means the function is now ready to integrate. And the leftover negative 8, we are going to bring it outside the sign of integration. So it's minus 1 upon 8 integral of minus 8 divided by 1 minus 8x and dx. So after integration is minus 1 upon 8 ln of 1 minus 8x plus c. That is your answer. So the same strategy we have applied almost in every subtopic of integration. While we are integrating the trigonometric functions, the main thing we focused on, if the derivative part of the angle is present, then you can integrate. So for every method we have built the strategies that we can apply in almost every subtopic of integration. Alright, so after that, after part F, we are going to start with part H here. Part H. It says integral of 4 divided by 2 minus 3x dx. Alright, first focus. I'm going to write down the question again. 2 minus 3x dx. What is the derivative of the function that is present in the denominator? It's minus 3, right? So we need to multiply and divide by minus 3. So this 4 and minus 3, I will take it outside the sign of integration. So it's minus 4 upon 3 outside, and inside the sign it's minus 3 divided by 2 minus 3x dx, right? Now the function is ready to integrate, so you can say that it's minus 4 upon 3 ln of 2 minus 3x plus c. That is your answer. Alright, so you have a time of 60 seconds to note it down in your copies, and then we will start the next question. So start. Alright, so after this question, moving on to the next one, it's question number 2. Again, from the new book we are following. Question number 2, so we are going to attempt some of the parts, starting with the first part. It's part A. Integral of 7x plus 1 plus 2 divided by x dx. Alright, so we need to integrate the following. So why don't we take the integration sign with all of them? What I meant is integral of the first one is 7x dx, right? Second one is 1 dx, and third one is 2 over x dx, right? We have applied the sign of integration with all these three terms. The first one, the integral of 7x, it will be 7x squared divided by 2 plus integral of dx is x plus the integral of 2 upon x, so that will be ln x plus c, and that is your answer. Alright, so now you have a time of 90 seconds to note down the solution in your copy. So start. Alright, so after part A, I hope that you get the idea. We are going to start with part C now. It says integral of 5 minus 3 upon x whole square dx. So give it a try first, and you have a time of 2.5 minutes to attempt this question. So start. So at first I will apply the identity here, so that will be a square minus 2ab plus b square. Alright, and now I will apply the integration with all these three terms. So it's 25 dx minus 30 integral of 1 upon x dx plus 9 integral of x to the power minus 2 dx. So the integral of 25 dx, it's 25x minus 30 ln x minus the integral of x power minus 2, it's x power minus 1 divided by minus 1, that is why I incorporate negative sign here, and plus c. We can write it in this form: 25x minus 30 ln x minus 9 upon x plus c, and that is your answer. Alright, I hope that you have done the same thing. And after that, after part C, moving towards part E here. Part E, it says integral of 3 minus 5x cubed divided by 2x4 dx. You can attempt this part with the help of separation of LCM. So first you need to give it a try. Time is 3 minutes, so start. Alright class, so first thing, when you apply the separation of LCM, so it's 3 divided by 2x4 minus 5 over 2 integral of x cubed divided by x4 and dx with both of these terms. For this one, 3 upon 2 as a coefficient, we need to take it outside the integral sign, and x power 4 shift it in the numerator, it's x power minus 4 dx minus 5 over 2 integral of x cube upon x4, it's 1 upon x dx, right? Now the function is ready to integrate. So it will be 3 upon 2 integral of x power minus 4, it's x to the power minus 3 divided by minus 3 minus 5 over 2, the integral of 1 upon x, it's ln x, and plus c. We can simplify, 3 and 3 cancel. So the leftover is minus 1 upon 2x cube minus 5 upon 2 ln x plus c. That is your answer. Alright, so moving on towards the next question, it's part G here. This one, part G. It says integral of 5x plus 2 under root x divided by x square. You need to integrate it, but before that you need to apply a separation of LCM first. So that will be 5 integral of x divided by x square plus 2 integral of, in the denominator we have x square, but x root is basically x to the power 1 upon 2 and dx with both of these terms, right? For the first one you can cancel it, so the leftover we have, it's 5 integral of 1 over x dx plus 2 integral of, bases are same and they are dividing, that means you can subtract the powers. So x to the power 1 upon 2 minus 2 dx. So it will be equals to 5 integral of 1 upon x dx plus 2 integral of x power 1 upon 2 minus 2, it's minus 3 upon 2 dx, right? Now the function is ready to integrate. The integral of 1 upon x, it's ln x plus 2 x minus 3 upon 2 plus 1. So I will do it separately so I can easily write the answer. So minus 3 upon 2 plus 1 is equals to 2 minus 3 plus 2, it's minus 1 upon 2. So it's x to the power minus 1 upon 2 x divided by minus 1 upon 2 plus c. So it will be 5 ln x, 2 2s are 4 with a negative sign, and x power minus 1 upon 2, if we shift in the denominator it changes its sign, plus c, and that is your answer. Alright, so I hope that this part is clear to you, and you have a time of 2 minutes to note down the solution in your copy, so start. Alright, done. I hope that all of you noted down the solution in your copy. Now the homework part is you need to attempt question number 9 from exercise 21.2 from your old book which we were following for the rest of the exercise, but this concept is introduced in the new book, that is why we need to practice some of the questions from the new book. So that is a practice question and it is very much similar to this type question as we have attempted question number 10. Question number 9 is almost similar to this one, in which you need to find out the area of the shaded portion. Alright, so I hope that you have a good idea how to solve the question which includes the integration of ln function. Alright, so I think that is quite enough for today class. Make sure to submit your homework on time and make sure to try all the questions in that time which I have given you during the session. Alright, so see you in next class. Take care and Allah Hafiz.